This is the endothermic and exothermic chemical reactions lab that you're making up on YouTube. You should have a document already on you at the moment, which is your answer document. This is where you're going to make all your recordings and observations. This is also where you do all of your analysis questions too at the end. You do these at the very end of the lab after you've done the entire procedure. So if you read the entire procedure and looked at all the materials, you can see here how we have a number of different materials. You can see that we have chemicals, we have hardware, we have software, we have computers, all of this good stuff, which I have getting set up right at this very moment. When we read through the instructions, we were going to open up a file in Vernier, which is the program that we use in order to get collection of data. And we're going to then measure out all of our chemicals. So I will be doing that in just a short bit. Open up your computer, you're going to be opening up Logger Pro. Logger Pro is a software that Vernier has created to go and collect data while you actually do a lab procedure. So I open up the file right here, the actual program. It's going to open up Logger Pro, and then I'm going to hook up all of my equipment. So I have a temperature probe sitting right there. I'm going to plug that directly into this thing right here, which is basically how it communicates to the computer. It's not really important what you call it. But I'm going to plug that in with one hand. Yeah, watch that. So I'm going to set you down for just a second. I'm going to plug it in. Plug in my USB cord right here into my computer, just like so. And now, at the moment, I see that it's reading 21.1 degrees Celsius. That's the temperature of my temperature probe at the moment. But the next thing I want to do in my procedure is to open up the file. So I click on File and then Open. It says that I'm going to find a file called Endothermic, Exothermic under the Chemistry folder for Vernier. It's the very first file of them. It's the very first lab that you're going to be doing here. And so it opens it up, and again, you still have a temperature, and you now have a title, and it's all pretty for you. So now you're all ready to record. So next, let's go and grab all the chemicals. The very first thing to do is to get some baking soda and also the citric acid. So get a scale and you get it on there with a weighing dish. That's a weighing dish right there. It's empty at the moment. Well, it's got a little bit of chemical in there, but you're going to actually put the chemical in there. At the moment, the scale is actually reading a mass, which is no good for you, so you want to zero it.
Can I have a custodian to the main office, please?
So then I got a mass of 0. So I'm going to measure out 10 grams. So I pre-measured this, and it should come out to be pretty darn close to 10 grams. Dump it out. That's pretty darn close. That's enough for me. All right, so next thing is get our citric acid. Citric acid is a cloudy material at the moment. I bought it at a grocery store because I ran out of the chemical grade stuff, so I'm using grocery grade citric acid. It's not really that important. As you can see right there, it's got a fairly cloudy appearance as you're making your initial observations before you do the reaction. So I see it's cloudy, and then I measured out a certain quantity in my graduated cylinder because I needed 30 milliliters of this stuff. So if I look there, I got a pretty good estimate of 30 milliliters. All right, might be a little short, but that's okay for us. So I got my citric acid, I got my baking soda, I'm ready to do the reaction. So in step number 6 of the procedure, you're going to take the temperature probe and you're going to put it into the citric acid. So we're going to put the citric acid into our styrofoam cup. Alrighty, and then put our temperature probe in. We're going to let that sit there for about 30 seconds before this. So then we want to begin the data collection by clicking collect after that 30 seconds is gone. All right, go ahead and do it, just to save some time. Now, initially we see that it's about 21.1 degrees. So that's our initial temperature to start this reaction. And then we're letting it sit there, and its data collecting is going on right now. So you can see it kind of slowly going as we're going along. It's a nice horizontal line because the temperature is pretty much staying constant. Alrighty. Has it been about 20 seconds now? All right, go ahead and put that in. Now, initially we see that that white baking soda and that cloudy solution of citric acid is now starting to fizz heavily. Alright, we're going to keep doing this until we see the temperature is not dropping anymore. And actually, just to show you that the temperature is dropping, you see the temperature probe is actually recording a temperature drop. So initially it was horizontal, now it's starting to drop. Continue stirring, stir it up, stir it. And as you can see, if we look back at the graph, it's starting to level off because now we're not seeing as big of a temperature drop. It's going to continue on. We're going to do this until we see that it's not a significant drop anymore. Or if we max it out to 300 seconds, we can do that too, but I don't know if we'll do that. Are you starting to see here, if we look at these bubbles, it was very vigorous. Now as it's going on, you might notice it's not as vigorous of a fizzing going on. We're not only seeing a temperature drop, but we're also seeing the biggest temperature drop, but we're also seeing the fizzing starting to slow down. Now that we've done this first reaction, we can make our final observations of it and see that basically the fizzing is kind of calmed down to barely anything. And what we want to do is follow step number 8, which is basically, after making our observations, we want to dispose of the chemical reaction, which is easy enough because we're just going to dump it down the drain. Now in step number 9, it says we want to click on the statistics button. So that's what we're going to do here, is we're going to click on the statistics button, which is located right there at the top, and you're going to see a box come up, a dialog box, which tells you some of the important information of the graph that was actually collected. So you see the minimum temperature right there, and you see the maximum temperature as well. And you can see the mean as well, but that's not really that important for this, and the median, and then standard deviation, and how many sample runs were actually recorded too. But as you can see right there, our initial temperature was about 21.14, and our final temperature was about 1.24 degrees Celsius. So we want to store the latest run. So we're just about at step number 9, letter B, and we want to store it. Basically, you're going up to your experiment menu, all right? And then we're going to click on Store Latest Run, which is right up top here. Click on it. And what ended up happening is it just made the line really fine. And it's basically stored in there. If you do not do that, you'll lose your data when you do the next run. Alright, we're now on to part 2, and I got my hydrochloric acid to measure out. Hydrochloric acid, as you can see right there in these 2 flasks and also in this beaker, look like water. Alright, that's your initial appearance of hydrochloric acid, so we're going to measure out 30 milliliters. Right now I poured a little bit too much, so I'm going to just kind of dump out a little bit, just about 5 mils. Doesn't take much, maybe a little bit more. And there, I got about 30 mils of hydrochloric acid ready to go. Magnesium. So I'm going to. My magnesium ribbon, which is sitting right over here. And I just need 1 piece of magnesium ribbon. As you can see, it's shiny. It's very, very thin. And you're making your initial observations of magnesium. There it is for you, all ready to go. Next step is the hydrochloric acid and magnesium. We've already made our observations before we do our reaction, so we have our magnesium sitting in the graduated cylinder, as well as our piece of magnesium bent up. And so the first thing is we want to put our temperature probe and our hydrochloric acid into the styrofoam cup and let it sit there. And magically there was 45 seconds that passed by. And we're letting it get to temperature, and we're going to hit collect again. So we hit collect, and it's going to start recording again. Now, we're just letting it sit there for the initial 20 seconds, and then we will add our magnesium and start gently stirring into our cup. Remember to make observations as you do this reaction. So after a 20-second mark, as you can see going still, very tiny, but I think you can still see it. We're going to throw our magnesium in. And as we look down that cup, we can make our observations. You can see that it's starting to bubble and fizz vigorously. You might even see some of the gas coming off the top of the cup. You don't want to be breathing in these vapors because that's hydrogen gas coming off that reaction. Alright, so we keep stirring gently as we're making that magnesium react with the hydrochloric acid. And you're seeing possibly some gases coming off from the video. But if you look at the graph now, we're making our observations. We're not only notice that there's fizzing going on, but we can see there's a definite increase in temperature. And as the bubbling starts to lessen, you're going to see that graph start to lessen. And actually, it might run off the graph. It might run right off the graph, as many of your classmates did. But we can fix that later. So we're going to keep stirring. And it does stink. Just to let you know, hydrogen gas is not pleasant to be breathing in. Alright, and it's barely fizzing anymore. I don't know if you can adjust that right now. Oh, right now it's at, you can see the temperature change went from about 20 degrees up to about 42. So you can see there's a definite increase in temperature. So 42 degrees, it looks like it's leveling off now because you can see it's not really changing. Well, it's actually starting to drop now. So if we look back, see our temperature dropping, look back at our cup, I don't see any magnesium sitting in there. So the reaction stopped, the temperature starts to go back down. So now that we've collected all of our data for both graphs and we see both of them sitting there, one of them's thicker than the other, we want to store the latest run for our hydrochloric acid and magnesium. So what we're going to do is, again, go up to the experiment menu, and we're going to click on store latest run. It's going to make them thinner now, so we have two thin lines. And now we want to also auto scale the graph to make everything look pretty, because if you notice the red line is running off the screen. So we want to fix that so it actually shows up, and then just by hitting auto scale, which is the button that's got a big old A on it, that will auto scale your graph to make it look visible for everything. Now we're going to move on to printing the graph, but we want to actually follow the steps. I did one little thing prematurely. I did letter A, which was the auto scale, which is in step number 17. We also want to do the statistics button on step 16 to get our information. So if we hit stats again, we want to do run 2. And we can actually see the information right here on my text box. I can see that my maximum or my minimum temperature, which was the starting temperature, our initial temperature for the second reaction, was 20.7 degrees. And the maximum temperature was about 42.1 degrees. And so you have that information to record in your data table. And now what we want to do is focus on printing. So we've done step 16, A and B. We got 17A as well done. Now we're going to move on to the rest of step 17. So now that you have the graph completely done for both trials, now you want to label the graph and print it out. Well, obviously you're not going to print, so you're going to have a blank graph to work with, and you're going to take note of what this looks like so you can sketch it yourself on the blank graph and then also label it. We're going to show you how to put text boxes on here so you can label them. Remember, in step number 17, part C, it says to label as one graph being exothermic or endothermic, and that's what you're going to decide. I'm going a little fuzzy there. So that's what we're going to do up here at the top of the menu, and we're going to hit insert, and you're going to see text annotation right at the bottom here. There it is. And you have this box that pops up. Now all you got to do is type in whatever you like. So we're going to say endothermic or exothermic. Again, you decide where it's going to go. We're not going to show you. And you can move those over if you want by just taking that little hand. It drags. And you can take that and just drag it. Sorry. And again, don't trust where this box is going. She's just putting it wherever. All right, so you decide which graph is the endothermic and the exothermic, but that's about as easy as it gets. When it comes to the text boxes on this program, you're going to hand write these into your own graph. And then you're all set and done. Just answer the questions that follow.